All right. So, any questions on anything to date?
I have a quick question. Okay.
Yeah.
Yeah. May I share my screen?
Sure.
Yeah. I installed the ISCE, the MinPad, and some related package on my local machine on my laptop. So, for the TOPS app, everything went well. But a weird question is about the strip map. Before the last step, the geocoding, everything goes well, but except this step. And I encountered some errors. I don't know how to fix them.
Did you run this on the system?
On my local machine. I installed the ISCE.
Right, but
Yeah.
you can't guarantee that anything that you're going to do on your machine is going to work.
Yeah.
Just from looking at it, it looks like you're running a really old version of Python.
Oh, okay. So do I need to update the Python version to like 3.8?
I don't know what versions it works for, but this is not a question that really that this course is set up to answer.
Okay, okay.
We are not here to do debugging of your own installs. That's why we run a system which is which we specify everything for. You're using an older version of ISCE than we used in the course. So
Okay.
2.4.2, we're running 2.5.1, I think.
Okay, thank you.
But have you used the notebooks on the server that we provide, the Openstar Lab? So
yeah,
that all works for you, right?
Yeah, sure.
Okay, good.
Or it could be that your version is old.
Okay. I installed ISCE last year.
Ah.
Yeah.
Oh, so yeah, you're still using the same version that you installed last year?
Yeah.
I see. Well, maybe try reinstalling it.
Okay, I will try it. Thank you.
Yeah.
Hey, Paul, this is Amit. I had a question about correlation. I just was wondering, I was just looking at the notebook and was wondering, when you calculate the correlation estimator, does it include both the amplitude and the phase part of the signal, or just the one amplitude part?
Okay, let's look at the formula. I'll bring it up.
Okay.
This is a preview of tomorrow's notebook, just hot off the presses. All right. So you are talking about this formula here?
Right.
Yeah, so S1 and S2 are complex quantities.
Okay.
So that's your complex SLC image.
Okay.
And if you go down to the actual way that we calculate it, that's down here. So you take the sum of the complex product of the first image times the complex conjugate of the second image. And then you, after you do the sum, then you take the magnitude of that.
Okay.
And then normalize that by this large formula, which is just the power. It's actually just the amplitude of square root of the power, shall we say, of image 1 and the square root of the power of image 2 after averaging.
Okay.
Right, so these are complex summations that you then detect using the absolute value.
Okay. Yep. What I'm trying to understand here is if, for example, if there is a change in the surface roughness, and without any change in the phase, the complex part or the phase part, we'll still see the change in the correlation coefficient, as well as if there is like from S1 to S2, there is change in the range because of some phenomena, but the amplitude remains the same, we'll still see the change in the correlation. What I'm trying to understand here is if there is a deformation or some kind of movement without any change in the surface texture, we'll still see the change in the correlation coefficient. Am I correct, or am I going the right direction?
So that's a good question. And the answer to that question is, I'm not sure anybody's done the electromagnetic modeling to answer it precisely.
Okay.
But let me sort of give you a heuristic answer.
Okay.
So you said, what if nothing changes in the electrical properties, but somehow the roughness of the surface changes? Wasn't that your first statement?
Right.
Okay, so if the roughness of the surface changes, what does that mean exactly? That means that each of these incremental scatterers which are in the cell, which could be pieces of, little facets of soil or a hedgerow or something that's radiating back or reflecting back towards the radar,
right,
those will reorient themselves in position. So even if their intrinsic dielectric property hasn't changed, this little path length here will have changed relative to the previous observation. So yes, you should see, with a change in surface roughness, a change in the correlation of that pixel.
Okay.
If nothing changed, except that whole parcel of land moved from point A to point B, with no change in the roughness, no change in other aspects, no change in the electrical properties. In that case, as long as you co-register those two pixels accurately, you should see no loss in correlation.
Okay.
Does that make sense?
That's what I'm trying to understand is how does that, the second thing that you explained, how does that happen?
Well, the way I think about it, which is in much less deeply than Paul thinks about it, probably, is that really the interaction of the radar with the ground has a phase associated with it, right? The ricocheting of all these radar plane wavefronts off all of these scatterers adds a certain phase to the pixel. And if nothing changes to that pixel, when you subtract the phase of one image from the phase of the other, that pixel term cancels, it goes away. So basically how InSAR works at all is that you're able to do this, in that most of the time, most of the scatterers are in the same places and their phase term cancels when you difference two images. It's when the phase response of the pixels for one of the images is different that you get decorrelation, that you basically, it doesn't cancel, and it is no longer predictable what the phase of that pixel will be. Does that make sense?
My thought, my take on his question was that he understood that part, but somehow when the pixel moved as a bulk unit, it somehow should still decorrelate. And I think maybe the conceptual issue is that if the entire image moves and you don't do anything to correct that movement, and you try to make an interferogram with the first image, you will be comparing pixels that are not properly aligned. And in fact, there will be a decorrelation of those surfaces. They will not correlate well. You have to align them in order to get that speckle pattern, the backscatter, the phase that Gareth was talking about, to be identical. So there is this process of alignment that must occur. Now, you might ask, well, does that mean that for every pixel in your earthquake, you adjust it to match up with its counterpart before it was shifted by the earthquake? the answer is that generally we don't do that because the shifts at the pixel level tend to be relatively small, and we can live with a little bit of decorrelation rather than going through all of the hassle of estimating that local deformation down to a very fraction of a pixel. And sometimes even because of decorrelation, just because of the jumbling of the surface, it's really hard to estimate that offset anyway. So we just don't typically, unless it's a really big signal, like on a glacier, which you're going to hear about tomorrow. And then you try to morph the second image locally to match the first image. And then you can not have this effect that you're worried about, I think. Does that, you seem to be nodding your head yes, so maybe that makes sense?
Yes, that's exactly what I was trying to understand. I don't have like, my background is civil engineering, so I'm just trying to understand what's the theory behind it or what happens here. And that gives me a better idea than what I had before. So.
Yeah, I remember, I hate to tell war stories, but back in the 90s, when I was first doing this, there was a big earthquake. And one of the things we were worried about was whether we were simply not, we had very limited data. So we wanted to extract every little piece of information out of it that we could. And one of the experiments we did was local correlations, the so-called dense offsets that you heard about at the end of today's lecture, and you'll hear more about tomorrow. We did that to try to understand whether we could improve the correlation significantly by locally deforming the earthquake signature. And it turned out that it made a little bit of impact. It helped a little bit in that particular case, but not enough to warrant the immense amount of computation that we needed to do at that time with the lousy computers we had. So we just didn't bother to do that.
Okay. Well, that makes sense. Yeah. Thank you.
Mm-hmm. It's a good question. Any other questions?
I had a question, but I think I just figured it out. So maybe I'll just share the solution.
Great.
After talking earlier, I had already started modifying the TopSap homework in the same directory. So I just, rather than making a new folder, I started there, and I thought I could kind of deconvolve the example problem from my homework. And it turns out it mostly works, except that when it's downloading the DEM, if you don't delete the old DEM, it tries to use the old one.
Oh, really?
And it doesn't check whether it's got the right bounding box.
That's kind of silly.
I think it dumps it in like some sort of a temp folder, and it just checks is the folder there. If yes, then like yay. So you can do it again. Yeah.
So yeah, so copying everything to a new, or copying the notebook to a new folder will be much more functional, would be much better, as was suggested, but I decided to plow through anyway.
Yeah, the other way you can do it, I guess, is with putting some sort of a link at the top to another folder and simply, well, that's risky too. Yeah, never mind. Don't do that.
Or the other way is actually you can change the XML file to point to a directory where all your DEMs get stored, right? And then it will just accumulate DEMs for all your notebooks, for all your processing. And if you happen to hit on one that you've used, the same area that you've used before, then it doesn't download it again, which is kind of cool.
So what happens then, other than the DEM? Suppose you did what Gareth said and you had a good local repository for DEMs. What happens for If you have two different tracks and you process them in the same directory, they have unique names down through the directory tree that allows everything to be deconflicted? It's kind of asking you, Emily, since you just did this.
Oh, I just deleted the old ones.
Oh, you deleted it. Okay.
Yeah. I was trying to rack my brain though, because the last time I did this class was with like ICE 1.0, and it was and so I'd been unable to update since then, just because I didn't know how to use the other stuff or the newer ones. But that's how I have my old one set up, is to go to a directory, but I don't have access to that computer right now.
Let's see. You took this class for ICE 1.0?
Yeah, I was a guinea pig for, I was the only remote participant about 5 or 6 years ago at some point.
Wow.
And it was like a
Just like that.
video camera set up in the back of the UNAVCO room or something like that. It was it was a good experiment. I got some useful data out of it, but not enough facility that like I said, I've been able to update the software or do any of these TOPS things, because TOPS wasn't a thing back then.
Was that the class where we did something like this remote OSL training, but using that Kluge system? That was the only time we ever did it, 2016 or something?
No, I think this was even earlier than that.
Wow.
I was installing it and working on my own machine.
Oh, I see. Okay.
Yeah.
Okay. Okay.
Can I ask a question? Am I audible?
Yes, please.
Yes. Yeah. So this was about downloading this NetRC file. So in the root file, so I've downloaded that, but I'm not able to process it. It's saying found a swap file by the name .nrc netrc, and it's saying while opening the file netrc cannot be found. So I not able. So can I share the screen?
Please.
Yes,
Do.
So this is what I am getting while I am trying to.
What?
I don't know. I made some mistake. I don't know.
Can you just do an ls-a on your
Control C, whatever you're
Control
doing.
C?
Control C.
Yep.
Yeah. Mm-hmm.
And so let's see, press enter to type.
What are you running?
What are you running? Yeah, where are you in? Okay,
So
do another
I
control.
just did
Just
vi.net.
quit.
Oh, you are the
quit
VI.
and,
Oh,
and quit, because this is when you open a file with VI twice, or whenever your session crashed and it stored this swap file. So he needs to get out of there, then delete the swap file, which is that .netrc.swp. And when that's deleted, then he can open the thing again with VI.
yeah. So get out of the VI.
Mm-hmm.
Usually,
So-
I think usually it's escape and then Q exclamation mark.
Enter.
No, press escape, the escape key. And then
Move
to Q exclamation mark enter. Are you in a VI?
So I just because I was asked to make this NetRC file. So I searched on net how to create this. So this is the first time I'm doing. So I found this command where it said vi.netrc, and then it said that the file is created. And then when I tried to run again, so I was getting that error.
Maybe just
So,
close this
Yeah,
particular
let me just, that's the best thing.
and open a
And-
new terminal.
Yeah, so this is our file. And let me open a new terminal. Perfect.
And now do ls-a
Let's
space -a.
see.
Okay, and enter. Okay, remove or delete all of all of these strange NetRC files that you're having there. You have a whole ton.
Mhm.
Do rm space .netrc star. And add a star, yeah, and then enter. And then do again an ls-a. Make sure that we got all of them. Okay. And now you can do, if you want, the vi
Mhm.
space .netrc. Enter. Okay, now you created the file.
Mhm.
Let's see, does anybody have what the content is? Is like do a do a type I, just the I key. So now you're in insert mode. Now you can insert content. I think
So the user ID, password, and then scene. Right?
user ID, I guess, whatever it needs to be. You can just type in.
So was this?
Yeah, I'm not sure if you can copy paste easily. You might want to open them side by side and just type it up. Okay.
So I'll just open it. And
And then before you, so let me, before you type in your password and share that with us all, what you could do, I can show you how to get out of the VI, and then you can stop sharing, get back in and finish.
Yeah.
So, you know, typing the I key gets you into the insert mode. You see on the very bottom where it says
Yeah.
insert, right?
Mhm.
So to get out of the insert mode, press the escape key.
Okay.
Okay.
Mhm.
And now you can do colon,
So after the password.
just colon, type colon, and do WQ, which says write and quit. Okay. And enter. And so now close the file. If you want to look at what you just did, you can use either less or more. Actually, either one of those works. You type in less, LESS, space, and then .netrc. And that basically just shows you what the content of the file is if you do enter. So this is what you have right now.
Okay.
So now what you can do is you can stop sharing. You can use the VI again to get into the file. So you do again vi.netrc or Emacs, whatever you feel right. Let's
And
use
then
the VI
insert
because
mode
we
and
started doing the VI. And then you can go again into the insert mode and type in your password, and then hopefully it works.
Okay, thank you. Thank you so much. Okay, we'll start.
Yeah, we needed to have installed Nano or some other simple editor.
I
Some
think
people don't like
Emacs is on
VI.
it, right? Is Emacs on it?
Emacs runs, but that's only simple to Emacs people, which is me.
I like the VI and the Vim. So
At least Emacs doesn't have to, you have to change for edit mode to other modes. It's all type and you typed it.
So Yi-Ching, your question about converting dB scale to linear scale, I'm not entirely sure, I can't remember the question, but if you are trying to use an SNR that's in dB to calculate correlation, then yes, you must convert to linear scale. And the Math Basics notebook, if you're not familiar with dB, will teach you how to go from dB to a linear power scale.
Can we resubmit homework?
Of course. This is very free.
it's cute that you think we've looked at it already.
If you if you submit it twice and you leave them both there, then we can give you double credit. No, we'll just take the most recent one. All right. Any other questions? So in general, have people been able to keep up with these homeworks, or have the logistical and just operational aspects of using the environment meant that you're kind of behind the 8 ball and behind? Or it's just not, the instruction's not clear enough for you to make quick progress?
I'm definitely behind. I'm super slow with Python though, so I'm kind of learning some of that as I go as well.
Okay. Yeah, I'm wondering if nobody likes these 8-hour days on Zoom, but I'm wondering if we shouldn't go back to an 8-hour day. What's that?
5-hour day.
What's that?
A 5-hour day maybe, because we should probably have an hour of slop at the end, like we have an hour of slop at the beginning.
Could be. I mean, when we do it in person, we start at 8, right? And we end at 5, right? So that's 9 hours. And there's a lunch in there, of course, so, and a couple of breaks. But
I
it
could
just
almost do like one segment of the class and then the homework assignment and then the next segment and then the homework assignment before I lose it in my brain by moving on to the next thing.
Mhm.
The last time we taught it in person, we were using very, very slow computers. That's the other thing. Like it took much, much longer to run everything than it's taking here.
That is true. That is a good point.
We've definitely upped our computer game since then, thanks to ASF and Amazon.
Yeah, I really like the environment, even though I'm taking some time to get up to speed on just kind of how the notebooks work and things like that. It's enabled me to focus on the content rather than just the installation process and making sure I've got all the setup on my own. I can fight with that stuff later. Yeah, I do like the organization, and the notebooks are really.
So one thing that I did do in the class to facilitate doing the homework, so I ran some of the notebooks that we're using this week also, is I had sort of, the lab contained what we do here. We basically go through the notebook, and then it had like an additional hour of people doing the actual homework. And instead of having every person do a separate homework, I had them do it in groups. And basically we took the Zoom and we divided it up into little breakout groups, and then each breakout group did the homework together. And this way, if there was a higher likelihood of one person being online that knew something about Python, and one person online that sort of understood more of the physics, and then as a group they could figure it out most of the time. And then what I did is I basically just circled around and sort of hopped from group to group.
I did the GMT-SAR course last month, or a month and a half ago, I don't remember. And they did that. They do like little breakout groups in Zoom. You can do that,
right?
But we were kind of time zone based, so depending on your time zone.
That's exactly what I was going to say. That can be a challenge with the time zones. Yeah.
Yeah. So I was kind of New Zealand, Asia, sort of area, Oceania. Yeah. I got a question. Do you have a sort of updated document manual from ISCE too? The one I found in the GitHub repository is from 2015. And it talks about InSAR app more than strip map. Sorry, TopSAR app.
Yeah, probably not. Documentation, as always, is the last thing to be done. And these notebooks are self-documenting, right?
Yes, sort of. But as soon you start trying to do different things, things start breaking up. And
yeah, example, I know. That this is one problem with sort of community-oriented software. I'm hoping that because ISCE3 will be the operational code for NISAR, and there's operational project funding for it, the documentation will be more robust, at least during the life of the mission.
Yeah.
ISCE2 evolved from research programs, and it's always difficult to get funding for the documentation. It's actually a lot more documentation than I ever thought there would be, given the way it evolved.
Yeah, because I was trying to change the ILUS data using the SLC directly instead of the raw data, and I just couldn't. I didn't. Yeah, trying to figure that a little bit, but then I said, just download the raw data. Is going to be faster than just trying to figure out where and which and how to change the start, and how to manipulate that different steps, and don't do one and sort of thing. Yeah, but
that's right. Yeah,
in one day. No. Yeah.
And probably not all the functionality in ISCE2 as documented in 2015 works anyway. For example, that very thing. Can you start from SLCs for ALOS 1? I'm not sure. I know you could at one point. I'm not even sure you can anymore.
Okay.
But I'll bring that up. We used to have a forum for ISCE2 on a website called EarthDef, and that was operational up until just a week ago. Oh. And it was taken down because of security reasons. And that had years and years of history of all the kinds of things. If you had a question about what you were just asking, I'm sure it would have been addressed on that forum.
Last time I looked at for a question that I had, I looked for an answer on there. I found that I'd asked the question 2 years previously. Also, got
Yeah,
closer
so,
to solving it
one
the
of-
second time.
Yeah, one of my tasks is to see if I can either resurrect that history or find a way to move it into another database so that people can still access it. Because I think it goes a long way to bringing the community's experience with the code forward. And I think ISCE2 will be around for quite a while, even after ISCE3 becomes available, because it is quite functional. And people are still adding new functionality to it. But I will check to see whether the ALOS1 data can be processed from SLC currently and see if I can find a simple script to do it. I thought you could just specify the steps that you do in the workflow and then specify in the XML inputs that it's an SLC, not a raw data file, but perhaps there's more to it.
More questions?
Maybe I can share something real quick related to the previous question about the offsets and coherence, because it's kind of timely. Let's see. Do you see my screen?
Yeah.
So this is one of the interferograms. Eric Fielding created this interferogram. This is from ALOS2 for the earthquake in Haiti a few days ago. And first of all, it's a little bit of an advertisement for NISAR, I'd say, because if you've seen the Sentinel-1 interferograms, they're pretty messy, but the LBAT interferograms have much better coherence. And so this has pretty good coherence, even though if you look at the acquisition dates, this is an 8-month interferogram. So if you think of NISAR having 12-day pairs everywhere, the information you would be able to get for this earthquake would be pretty dense and pretty high. But anyway, you see that's the interferogram. The interferogram looks largely coherent, with the exception of some places where either was damage or over the 8 months maybe there was some change. But if you then unwrap the interferogram and you calculate the absolute deformation that happened, this is what you get. So this is radar look direction in this case was from from the side, and you get a pretty good idea of what the deformation was in meters. So it's between minus 0.5, minus half a meter in the dark red, and plus 0.8 meters in the dark blue. And so that's what you get in the phase. But what he also did is he looked at what Paul Rosen talked about earlier, is like, what if we just calculate the offsets? And you can also calculate the offsets, and you get this. And you get about the same amount of offsets, plus minus 0.8. You see that they are consistent with each other. So the phase here and the offsets are somewhat consistent with each other. But the phase, of course, provides much higher accuracy than you can achieve with offsets. You see there's much more noise in the offset estimate. But despite this offset of like plus minus 0.8 meters, the interferogram is perfectly coherent. This interferogram is processed at the 80 meter resolution. So an 0.8 meter motion, which is a pretty large motion, is still only about 1/100th of a pixel. So the impact on coherence here is fairly small. So it shows you that we can cope with that amount of offset and still get coherent information. Yet at the same time, what you get from offsets by just looking at sub-pixel offset estimates is consistent with the information that you have in the phase, just of less accuracy. So it's quite a nice data set that Eric put together for this event.
Yep. And it looks a lot better than the Sentinel, which is just 12 days apart.
Yes. That's why I say it's an absolute advertisement for ISAR.
Yeah. So Rodrigo, if you go to the bottom of the StripMap app notebook, I think it lists the, it says sample input XML for different sensors. I think it's a little bit more strict than just sample inputs. I think they are the inputs that StripMap app and ICE can handle these days. So NBSat, I think it's NBSat raw data, Sentinel-1 SLC bursts, ALOS-2 SLCs can be handled, ALOS-1 raw data, Cosmos SkyMed raw or SLC, TerraSAR X only distributes SLC. I think that's basically the functionality these days, but it's not explicitly stated, so it should be probably stated that way.
Okay, thanks. I'll look more in detail. Yeah.
See, it does say here it's been explicit. Now that I just said that, it says right above it, ALOS-1 has been explicitly tested. Sorry, the StripMap app has been explicitly tested on ALOS-1 raw and SLC. ALOS-2 SLC. I am not sure about that. I am going to follow up with people on that. I'll let you know by tomorrow.
Thank you.
Yeah.
Leanne, good question in the chat about, can you use TopSap to look at, building deformation where the settlement might only be 1 centimeter. One interferogram is probably will have difficulties get you to the 1 centimeter scale robustly. But later in this class, we will be talking, first of all, about stacking, about creating a stack of interferograms. And we'll create a stack of interferograms and then use it using time series analysis with a tool called MinPy to more get to the centimeter scale deformation level. So we'll talk about that a little bit. The question is a little bit loaded because the building deformation there's really 2 limits that you're applying here. One of them is the absolute deformation, which is really probably what you were after. And so MinPy will get you closer to that, or near that 1 centimeter deformation accuracy. But the other question with buildings is also resolution. The approaches that we focus on in this class here, they are based on techniques that are falling into the concept of short baseline subset processing, where we apply spatial filtering to the interferogram to suppress noise. We then unwrap interferograms individually, and then use MinPy to estimate time series from these interferograms. Those Approaches are really good for the sort of the geophysical case where you often look for signals that are a little more spatially extended, like an earthquake signature or volcano signature. If you're looking for building type deformation, which is very localized potentially, you might be better served with either a persistent scatter type approach, which works at the full resolution data set, or possibly approaches like that are, I don't know if they are nowadays under the umbrella of SqueezeSAR. SqueezeSAR maybe is more one type of covariance matrix-based InSAR approaches, where you try to basically filter very adaptively, and in places where you have point targets, you try to not filter the data. In places where there are distributed targets, you try to filter. JPL actually has a package, I think. Fringe package, which supports this kind of processing. Maybe in a future version of this course, we could even think about.
It has even less documentation than ICE. But it starts with the stack processor. And there are also now pathways for using the stack processor to use stamps, which is a PS code. I started typing an answer to you before my internet went out, saying at least some of what France just said.
Okay, good to know. Thank you so much.
Yeah, time series analysis is the key. There are different kinds. There are two main groups, sort of more the point target based ones and the distributed target based ones. And mostly in this class, we focus on the distributed targets where there's filtering involved. And those are not necessarily ideal for these very small scale, very localized deformations. So if you think of the collapsing building in Florida that happened, I don't know how many weeks ago now, it's not necessarily the approach of choice for looking at buildings at risk, but a fringe or sort of a more point target based approach like the ones you get in the STAM software that Gareth mentioned, or approaches that combine the two, such as the one that is implemented in the fringe package. Those would be more appropriate.
Yeah, thank you. I just ran the TOWS app notebook, and here's my result. Basically, there is a tunnel alignment, but I didn't find any signals here. Yeah, because of the deformation is too small. Yeah, thank you so much.
Yeah, there's a question about, so we have worked with the MinPy team and actually Forrest, I think, who is in that, is he in that class? I think he is. Forrest, who is actually one of the class attendees, he wrote a component, an addition to MinPy that allows you to take custom processed interferograms from ASF and work them through MinPy.
All of the ARIA interferograms are also on ASF, right?
Yes, the ARIA interferograms are also on ASF. Those work natively with MinPy because they are created with ICE in the standard ICE way. So the ARIA interferograms are easy to work with MinPy. And the ones you get from the ASF custom processing pipeline, you can use those with MinPy nowadays too.
We'll do ARIA, I guess. Thursday,
Yeah, for the
Friday.
class, I think we'll do an ARIA stack.
Yeah, I was just following up the GitHub, and I saw like about a month ago there was still some issues with that, but I didn't know how far has it gone.
Yeah, there's some issue tickets, but those issues have all been resolved. It may not be reflected on GitHub yet, but they have all been fixed.
Okay, so the repository, whatever is available in the GitHub, like it should work, right? That's what you're saying. Okay.
Yeah, the main thing that needed to be done in the ASF custom processing pipeline is to make sure that the interferograms have, there was one layer missing that ASF didn't right away deliver, and that was added in. And so I've seen a test of this just a few days ago. This is a MinPy time series using custom processed interferograms over, that's I think Ferradinho volcano in the Galapagos. That's the deformation time series. So conceptually, this all works now.
Wow, I mean that's a goal for me.
Well, it's an easy target.
Oh,
Galapagos is always great because your coherence is decent and it so reliably deforms. It's always nice to show off. It's not a hard case.
Yeah, but I mean, the ISCE is, I mean, since I don't have much background, it takes time for me to actually get everything done. But the ASF interferogram, and if I can just put that into MinPy, that will be something to show to my advisor right away. Yeah. Yeah,
I mean, it's important that you all learn how to process an interferogram. I think that was important to do today.
Right.
Once NISAR is being launched, NISAR will actually provide interferograms out of the box, operationally processed for every image. So a lot of the interferometric data that you need for time series processing for NISAR will be created by the project directly.
Wow.
So you'll be in a pretty good position to start doing the time series right away.
Wow. Yeah, I'm really happy to hear that. Yeah, thank you.
There's a question about Fringe. I haven't worked with Fringe a ton. I would assume that Fringe still uses some basic topographic phase removal.
Yeah, I would have thought so too. That's a great question for Haresh next time you see him.
Yes, which will be tomorrow afternoon.
In theory, if you have enough interferograms and you have enough diversity of spatial baselines, you can separate deformation phase contributions from topographic phase contributions by using stack processing, such as the ones that's done by Fringe. For doing this with Sentinel-1, there's some limitations because Sentinel-1's spatial baseline is always short. So it's not as easy to get a very reliable estimate of the topographic error. So it's always worthwhile to remove as much topography as you can beforehand, based on DEMs that you already have.
Yeah, it's possible. That's a possible an optional step in MinPy is the estimation of the DEM error.
All right. Hey, when do we want to do a group photo tomorrow?
It's scheduled for the end of the day, isn't it?
Yeah, we should do it earlier. Some people, have to drop off, and maybe.
Yeah, we have more people sign in the morning or right at the beginning than we did today when they signed off.
True.
Should we do it just before the first break, or?
Did I miss some discussion? Is it already scheduled?
It is, but we could shift it earlier.
It's on the syllabus, apparently.
Is it?
I didn't know it either.
Well, I didn't understand that because somebody was asking, should we have one? So.
Yeah, I asked because clearly I didn't read the syllabus.
Oh, okay.
We're getting laughs from inside the room here.
There it is. Okay. Yeah, so maybe if end of the day is not best, maybe we should move that up.
How about
Anyway.
after the homework review?
Right, yeah, at the end of the homework review. Not everybody dials in for the homework review.
After Brent's?
Yeah, maybe just at the lunch break or the noon break, we should do it.
Somebody's got to figure out how to do these things so that it'll just, if you want to be in the picture, you just like turn on your camera at some point and then Zoom will just extract everybody's, not everybody actually has to be there at the same time.
Yeah, I was looking if Zoom allows you to sort of freeze the grid. Because the problem with Zoom is somebody speaks up or somebody makes some kind of noise, then he sort of jumps around. And so if you take like 4 screenshots, you get one person 4 times and other people not at all.
Everyone has to mute.
Yeah, maybe that's it.
All right, that sounds good.
Guys, see you tomorrow.
Very good. Thanks, everybody. Have a good evening or wherever you are.
Morning.
Morning, yeah.
Goodbye.
Bye.
See you.